everyone. Thank you for coming to my talk today. I will be discussing near-infrared, also known as near-IR, and showing a near-infrared camera and telling you how it works. So, a little bit of background. As you may or may not know, light can travel in a way that's very similar to like the ocean or at the beach. It travels in waves. And the way that we can characterize different types of light is with wavelength. Can I use the board really quick? I hope that's okay. But sometimes waves can look like this, and sometimes they're more like this, and sometimes they're like really fast. These are all waves, but we have different ways to tell them apart, and that's the wavelength. So going back to the slides, the wavelength is from the peak of one wave to the peak of the next. And so looking at the ones back on the slide, this one has a much shorter wavelength. It's from here to here. And then this one has a longer wavelength because it's all the way from here to here. I didn't even get to that next wave. So that's what a wavelength is. And we can look at this in our real life. So as you can see on the left, we have much longer wavelengths, and on the right, they're much shorter. So on the left, we have radio waves. So if you're ever in the car and you're listening to the radio, these are detecting radio waves, and they're super long, about the length of a building. And then on the right, we have gamma rays. They're very, very fast and very, very short wavelengths. And these have the wavelength of maybe an atomic nuclei, about a billionth of the width of your hair. So really, really tiny. And then in the middle, we have this. You can see it's like red, orange, yellow, green, blue, purple. This is our visible spectrum. And this is what we see from day to day. When I look around, I'm seeing the visible light being reflected off of things, and that's what I'm seeing. And then right next to that, we have infrared. And this has a wavelength about the size of the very tip of the needle, very small. And this is actually light we can't see, but it's right outside our visible spectrum. And that's the one I'm going to be talking to you guys today. And since I'm going to be showing you a near-infrared camera, I figured I would tell you a little bit about how cameras work. So there's actually two main components that are doing most of the work here. It's the lens and the sensor. So the lens takes all the light from the outside world. In this case, it's a house. And a house is maybe, 30 feet tall? I don't know. It takes a really big image, and it collects all that light and shrinks it down into something really small on the level of centimeters, and that's our sensor. So the light gives the sensor an image, and what the sensor does is it has to remember that image. And yeah, that's pretty much what's happening in a camera. And this is not only the camera I'm going to be showing you today, but also the camera you have at home, the one on your phone. This is all cameras. There's a few major differences between the two, though. First of all is when you're using your camera at home, you might notice it doesn't work in the dark with the lights off. This is because what's happening when you take a picture is the light is reflecting off of everything in the room and going into your camera or your eye, and that's how you see it. Whereas if that light wasn't there, then you wouldn't be able to capture it. And in an infrared camera, they're often used in the dark or when there's not necessarily a natural infrared light source, so it has to have its own light sources. So that's what we see at the top and the bottom. And then the second main difference is with that sensor. So what you're doing when you're taking a picture with your phone is it's trying to imitate what you're seeing in real life. So it uses those visible wavelengths. But over here, we're going to be using the wavelengths in the near-infrared range. So the sensor has to be sensitive to different wavelengths. A few applications. You can see how healthy plants are. So over here, it's a brown field. Is there plants? Is there not? We have no idea. But then if we combine it with a near-infrared image, and this one on the right, it's also been modified to see the contrast between more easily. But we combine the images and we can see clear differences between the plants and the grounds. You can tell those plants are nice and healthy. And this is especially helpful if, let's say you have a farm, you have a lot of acres of land. You don't have time to go look at all your farmland. So this is a good application for that. And then along with that, we have fruit and vegetable inspection. So on the left, we see a normal looking apple. Looks pretty yummy. And then on the right, we can see that once we look at it with a near infrared camera, it actually has this really big bruise on it. It looks like someone might have thrown it on the ground or something. Not as delicious, but we wouldn't have been able to tell that with just the visible light. So that's another application. And then what I think it's used mostly for is security monitoring. Here we see a man in the dark. He's in the dark. He doesn't know that he's necessarily on camera. He can't see the light around him, even though in this picture we can see the light. And that's because, as mentioned earlier, our eyes are not sensitive to the infrared light, so we can't see it. But the camera can. And another downfall of these cameras is that, like I talked about earlier, it has the light source is coming from the camera. So you're kind of limited by that light source. So if we look in the corner, let's say there was someone crouching in the corner right over here, you might not be able to see them, and that's because that light source isn't getting there. So let me show you that really quick. And I'm going to turn the lights off. Okay. So here's me on the infrared camera. I look kind of spooky. You might have seen something like this on Ghostbusters or something. But no one in the room with me can see me, but you guys can see me, which is kind of creepy. Another use for it is in looking at old paintings. So on the left we see an old knight. He has a nice silver hat on. And then if we look at it with an infrared camera, we can see that when the person was painting it, it looks like they drew a feather on the hat and then didn't like the look of it and painted over. And yeah, so we can see the mistakes of the artist and what it looked like before and after. You guys, first, I don't know, try to guess what this is. I doubt you'll be able to guess it because it just looks like a red canvas. Same with this one. Just a big red canvas, nothing to see here. But now, if I go over to the infrared camera, and I'm going to turn the lights off. So, you know, even if you couldn't see the red, you would have no idea what's on this camera because, you know, you can't see anything. So this is that smaller canvas that I showed you. And if you look, you can actually see our U of A wildcat, Wilbur. Yeah. And there he is. And then on that second one, this one's a little harder to see. Partially probably because it's so big. But we have our College of Optical Sciences logo. You can definitely see at least lines are on there. So once again, you can use infrared light to see stuff that you can't see in real life. And then finally, you can use it to tell if money's real or fake. So believe it or not, sometimes people fake money, and it's not cool. But we can tell the difference between the fake money and the real money using a near-infrared camera. So it's going to have these two stripes on it, and it's just like a normal $10 bill. There's no stripes on it or anything. It just looks pretty standard. But then if we look at it with the near-infrared camera, sorry, one side, you can see that there's actually these stripes on it. So this is actually a real $10 bill. So pretty cool. They might use these in grocery stores or something like that. The final application is something that's much more new and recent. It's the James Webb Space Telescope. I'm not sure if you've heard of it. I recommend you look it up. There's a lot of good information on it. It's essentially a telescope that was shot up into space, and it's there to look at all the new. It's maybe the formation of a galaxy, maybe population of stars in nearby galaxies, maybe young stars in our current galaxy. And this is a cool little picture of it. But it uses near-infrared camera to be able to see these things. And so it also has what's called a coronagraph. It's pretty cool. Pretty much if you were looking at the sun and there was like something, maybe a balloon really close to the sun, and you're like, what is that? You wouldn't be able to see it because the sun's too bright. But if you had a coronagraph, what it does is it takes the brighter object and sort of dims it so you can see that less bright object next to it. So yeah, that's some new, fun, exciting applications of near-IR cameras. And I hope you all enjoyed learning today with me. And go look up the James Webb Space Telescope.